Hi everyone, Miss Martin here, and today we are going to experiment with storing energy using this Twistomatic activity. If you have the supplies, you're more than welcome to try this at home, and you can follow the directions from Monday's assignment. So let's watch the intro first, and then we're going to experiment with two types of Twistomatic rides.
In today's activity, you're going to build a new amusement park ride for the company Acme Amusements. The ride is called the Twistomatic, and it works by twisting rubber bands, which store energy. When the rubber bands are released, they use all that stored energy to spin the riders around and around and around. Now, the real full-sized amusement park ride hasn't been built yet, so today you'll be testing a model, a smaller version of the Twistomatic. Your goal is to figure out how to make the most exciting ride. We'll show you how to get started, step by step.
So we have our two models already set up for us. You can see, first we're using a wide rubber band, and it's secured to a ruler. And then we also have a thin rubber band. And our job is to make this the most exciting ride, which means how can we make it spin around the fastest? So our first goal is to make this ride spin when I release it 5 times. So let's wind it up first. Kind of just like a winding tour. What we're going to do is give the rubber band, this is the thick rubber band, some stored energy. And I'm curious to see if I can get it to spin around 5 times, and I'm going to count how many full complete rotations we get. So I've just turned it about 5 times. I'm going to release and let's count. 1, 2, 3, 4, 5, 6. All right, more than 5. Let's try to get it exactly 5. Let's say we will have a time limit on our thing. So let's wind it up 3 times. See if we can get it to exactly 5. 3, 4. All right, let's try it one more time. 1, 2 turns, 3 turns. Let's go to 4 turns. And let's count. 1, 2, 3, 4 and a half. Looks like 5 turns is going to be the winner. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Perfect. So I had to turn it 5 times with the thick rubber band to get 5 full rotations. Let's see how the thin string does. Let's start with 5, just like last time. 1, 2, 3, 4, 5. All right, and then I'll release. 1, 2, 3, 4, 5. Let's try that one more time. 1 full turn, 2 full turns, 3 full turns, 4 full turns, 5 full turns. 1, 2, 3, 4, 5, 6. Very good. So it looks like this one goes a little bit slower. It's not as exciting. All right. If I were to wind it up even more, let's see if we can make it a bit more exciting. 4, 6, 7, 8, 9, 10. And as you can see, it's getting nice and twisted. That's about 11 full turns. See if we can make the ride more exciting. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, so the way this Twistomatic ride worked was using stored energy. So it was easier to make this ride with the thick rubber band go faster. There's more stretchiness in the rubber band, so it has more potential to store energy. It goes much faster. And to get the same results, we've got to almost turn this guy double the amount of turns to get just as much of a speed with the thin rubber band. And it's still kind of slow. All right, so the big question is, this is a model. This is something to kind of give us an idea of how to set up a ride like this. What would you use in real life to make a ride like this? What kind of real equipment or real types of ways to store energy could you possibly use? Let's go ahead and watch our wrap up.
The Twistomatic might not seem like any kind of ride in real life, especially not one made from rubber bands, but there are actually amusement park rides that make use of elastic bands, like this, called the slingshot ride. And even though there's no spinning involved, what's happening in terms of energy is very similar. When you either pull back on a rubber band or when you twist a rubber band, like you did in the activity, the energy from your body gets stored in the rubber band. Or to be more exact, the energy from your arm muscles is getting stored in the rubber band. That's energy that came from the food you ate. When the rubber band is released, the stored energy gets released too, which is why your Twistomatic would spin. But why did the thick rubber band spin faster than the thin rubber band, even though you gave them the same number of turns? We're hoping you noticed that the thick rubber band was a little harder to turn. Because you had to use more energy to turn it, that means more energy got stored in that rubber band. Which is also why when you released the rides, the thick rubber band spun around a lot faster compared to the thin rubber band. In other words, the more energy you put in, the more energy you get out. The more energy stored in something, the more energy it can release. If you did want the thin rubber band to go as fast as the thick one, then you had to store more energy in the thin one by turning it around more times. Again, because you added more energy, it released more energy. It spun around faster. Notice how there's a connection between energy and speed. The more energy you store in something, the faster it goes when that energy is released. Or to put it another way, if you want something to go really fast, you're going to need a lot of energy. And that makes sense with other things you've probably noticed before. For example, the faster a car goes, the more gasoline it uses. The faster an Olympic athlete wants to move, the more food they need to eat. What if we had used an even thicker rubber band in the Twistomatic? Not one this thick, but one more like this. Well, let's have a look. Let's spin it up. It takes a lot of effort to spin this one. Whoa, you see this? Look at how much that thick one spins. If you liked using rubber bands as a way of exploring the connection between energy and speed, definitely check out some of the other activities you can try, which we've linked in the optional extras. Have fun and stay curious.
All right. Make sure you answer the questions to the best of your ability, and thanks for joining me today.